Hello students, today we're going to do an example of a proof with parallel lines. So in this figure we're told that R is parallel to S and 1 is congruent to 3. And we want to prove that P is parallel to Q. So the first thing that I want to do is I want to state the given information. So step 1 is I can say that R is parallel to S. How do I know that R is parallel to S? Well, because it says so in the problem. And anytime I have information that's given to me in the problem, I put the reason for that as being given. Now there's another piece of given information. Angle 1 is congruent to angle 3. Angle 1 is congruent to angle 3, and that is also given. Now, what I want to do is prove that the line P is parallel to the line Q. So in order to do that, I'm going to start using the different theorems that I've learned so far. Now, the first thing I want to do is look at the fact that 1 and 3 are congruent. So I'm just going to mark these. Angle 1 is congruent to angle 3. So for step 3, I want to pay attention to R and S. R and S are parallel, which means that I'm allowed to use any of the parallel lines theorems that we've learned before. So specifically, if I pay attention to angles 1 and 2, since R and S are already parallel, I can say angle 1 and angle 2 are corresponding angles, which means that they're congruent to each other. So I can say angle 1 is congruent to angle 2 because of the corresponding angles theorem. Now for step 4, if I look at steps 2 and 3, I see angle 1 is congruent to angle 3, and angle 1 is congruent to angle 2. And so what I can say here is taking step 2 and flipping it around, I can say angle 3 is congruent to angle 1, but then step 3 says angle 1 is congruent to angle 2, which is congruent to angle 2. So if angle 3 is congruent to angle 1, which is congruent to angle 2, I can say angle 3 is congruent to angle 2. Now, the reason for that is if angle 3 is congruent to angle 1 and angle 1 is congruent to angle 2, then angle 3 must be congruent to angle 2. That is something called the transitive property. I know we've talked about that before, but the way I remember that is it's like a train. We make a train of congruent things, and then we just take the front and the back of it. We say that those are congruent. Okay, so now we've established that angle 3 and angle 2 are congruent. So if I look at where angle 3 and angle 2 are, I notice that those are alternate interior angles. And since the alternate interior angles are congruent, then those two lines must be parallel because of the alternate interior angles converse. So at the end, I can say step 5, line P is parallel to line Q because of the alternate interior angles converse theorem.